So what if we have a quadratic equation, in the form ax squared plus bx plus c equals 0, and it doesn't factor? What do we do? Oh yes, we could cry, but that's not going to help anything. So we need to find another way. And so our definition for the day is the quadratic formula. Given ax squared plus bx plus c is equal to 0, then what we know is that if this does not factor, then x is going to be equal to the value we get from this formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll say it again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, a, b, and c are the numbers in front of x squared, x, and the constant itself. Okay, here's our first problem. X squared plus 7x minus 2 is equal to 0. And what we want to do with this is we need to first of all figure out what a, b, and c are. So a is the number in front of x squared, which is 1. B is the number in front of x, which is 7. And c is the number that is the constant, which is negative 2. Now, we've got to take these three numbers and plug them into the quadratic formula, which I have already written over here. Again, you have it at the top of your paper. Okay, so using this formula here, it says make a negative sign and then put in b. So that's negative 7. Plus and minus. Now the plus and minus is there because quadratic equations have two answers, and that's how we're going to get our two answers. B squared, so that's 7 squared, minus 4. In parentheses, I'm going to put a, which is 1, and c, which is negative 2. And then I'm going to put that all over 2 times a, 2 times 1. Okay, now it's a matter of simplifying this. So the negative 7 sticks around. Plus and minus. I follow order of operations inside the radical. This is called the radicand, in fact. 7 squared is 49. Now, what I have here is I have a situation where I've got a minus and another minus, so I'm going to multiply those and make it a positive inside of there. And 4 times 1 times 2, multiplying everything that's there, gives me 8. So the denominator then is 2 times 1, which is 2. So I'll go over here. The negative 7 stays, plus and minus. Now the 49 and 8, I have to add those first and get 57. And that's all over 2. Now, crazy 2. So, not much better, is it? Here we go. So, third time's a charm. So negative 7 plus or minus the square root of 57 over 2. Does the square root of 57 simplify? Well, it has no perfect squares in it, so this is what x is equal to. These are our two answers. Now, if we wanted to put this in a calculator, this would be negative 7 plus the square root of 57 over 2, and negative 7 minus the square root of 57 over 2. Doesn't come out to be a nice answer. So one more quadratic equation for you where we're going to use the quadratic formula. And here it comes. So here's our last one, 3x squared minus 6x plus 1 is equal to 0. There's our quadratic formula off to the side again. And you might think, gosh, I'll never be able to memorize that. Well, with practice, you will. You'll get the hang of it really quick. Just like the more you write down your address or say your phone number, hey, the more that you're able to stick with that. So a in this case is 3. B is the number in front of x, which is negative 6, and c is the number that's left, which is just 1, and we're ready to plug things in. So it says, according to our formula, that we need, in this case, we need this negative b right here. So that's going to be a negative. Now b is negative 6, so it's a negative negative 6. plus and minus the square root of b squared, that's negative 6 squared, notice I put that in parentheses, minus 4 times a, which is 3, times c, which is 1, and that's all over 2 times a, and a is 3. Alright, so I'm ready to clean it up. Negative times a negative 6 is positive 6, plus and minus. Now negative 6 squared is 36, and 4 times 3 times 1 is minus 12, and that's all over 6. Now order of operations tells us that I need to continue to do the radical or radicand, so I'll subtract the two numbers inside, which is 24, all over 6. Now I'm not done, because, and I'll just segue up top here, the square root of 24 actually has a perfect square in it. Okay, so this is 6 plus or minus. Now the square root of 24 is actually the square root of 4 times the square root of 6, all over 6, which we can simplify that. This becomes 6 plus or minus, the square root of 4 is 2, the square root of 6, all over 6. Now there is one last step that I've got to do. What I've got to do is I've got to treat each of these terms here that I'll circle, 6, 2 square root of 6, and 6, as 3 separate terms. So what I've got to do is I've got to see what do they have in common. Now, I can't take anything out of the radical, but I can look at the front, put my 6 back, and think, okay, what goes into the 6, the 2, and the 6? So I can take a 2 out of each. That leaves me with 3 plus or minus the square root of 6 all over 3. And that's what x happens to be equal to. And that is how we work with the quadratic. So the quadratic formula is used with quadratic equations that do or do not factor. It can be used in both. It's quite a bit of work to use this when solving something that does factor, though. So a lot of steps, and that's how we can use substitution of numbers into this formula. And you're too kind. You're too kind. But hey, that's all you guys. That's all you. So thank you very much. And hey, we will see you another time. This concludes this concept with the quadratic formula.